Hey everybody, this is Mr. Bergman here, section 9.23, adding and subtracting rational expressions. Day number 3. Here we go. Just a couple of quick reminders. First of all, I want you to remember to avoid the big canceling mistake. I want you to cancel factors that are separated by multiplication, not terms that are separated by addition. So it's going to be really important to make sure everything is in factored form. To simplify, and when the instructions say simplify, that just means one fraction with all the canceled factors. So for that reason, you can actually leave the answer in factored form. Factored form is the goal, it's the way, and it's the ends. And so the first step is going to be, if you don't see anything in factored form, make it in factored form. Factor everything like this. So you can see this first problem. You've got to factor the denominators. And I show the work elsewhere, but you can use a box, you can split the middle, however you want to factor. And now that it's in factored form, you can actually start using it. Notice you can see there's two different things in the denominators. There's a 4x minus 7 and an x minus 4. There's also an x minus 1 and a 4x minus... Oh, wait a minute. It's kind of like AB times CA. I don't know. There's the least common denominator is 4x minus 7. It occurs in both times. So what you have to do is you have to get common denominators by multiplying the left fraction by the factor it doesn't have, x minus 1. You can multiply the right fraction by the factor that it doesn't have, x minus 4. Looks like this. So after multiplying the left by x minus 1 and the right by x minus 4, this is what we have. And now we have common denominators. So that means you can add the numerators. I'm just going to write the numerator for the next couple of steps because the denominator is so huge and doesn't change at all. So the numerator turns, after you do the distribution and add the two fractions together, the two numerators become one numerator, 6x minus 6 and 2x minus 8. We can combine like terms, and we can even factor the numerator. After you factor out a 2, because they're both even, you get 2 times 4x minus 7. But wait, hold the phone. 4x minus 7 occurs in both the numerator and the denominator. This is in factored form. We're going to cancel out the factors that are in both the numerator and the denominator. And so then you can see the only thing left in the denominator is x minus 1, x minus 4, and I want you to figure out what's in the numerator. What's left, what one number is left in the numerator. Moving right along, you can see here, not in factored form. So u squared plus 2u minus 6 turns into u plus 3 times u minus 2. That's because I factored. And now we can see that there are, in order to get a common denominator, we have to multiply these fractions by something, by the missing factors. Well, what's missing on the left is u plus 9, because the least common denominator is going to be u plus 3 times u minus 2 times u plus 9. There's all the factors that are present in all the fractions. So this one needs a u plus 9. The middle fraction here is missing both the u plus 9 and a u minus 2. So we have to multiply that middle fraction by those two different factors. And then you have to multiply the right fraction by the things that it's missing. It's missing a u plus 3 and a u minus 2. U plus 3, u minus 2. Okay, so the least common denominator has all three, and all fractions have all three factors. Great. Now we got to go to town on that numerator. Again, I'm going to only write what's in the numerator for the next several steps because the denominator is big and doesn't change at all. So the numerator is going to be, after we combine all these things, this minus this plus this. All right, in order to simplify, we do have to distribute. We do have to box FOIL. And when we do that, we get this first numerator minus, well, it's all in the numerator now, but the first distribution looks like this, and then when we box When we FOIL this out, we get here. And when we FOIL this out, we get this. Let's distribute. When we distribute, this is what we get. Again, we're only looking at the numerator because the denominator doesn't change. Then let's combine like terms. And after we combine like terms, you can see this is what we get. Question is, can we factor? You should look at it. And I did. Let's see, box factoring, you have to multiply the 5 times the 6 to get 30. And what two numbers multiply up to 30 and add up to 9? No two easy numbers, so it's not going to factor, and that's our final answer. All right, let's start looking at some equations. Everything of the past couple of days have been just expressions, combining expressions. But now we're actually going to solve. So noticing right here, the first thing I notice is that there's an x plus 7 in the denominator of this equation. So one thing we got to make sure we be very careful of is that if we somehow do all the algebra and at the end of the day it says that, oh yeah, I know what the answer is. The answer is -7. X should equal -7. It's not going to work because you try and plug it back in the original and you're going to get a 0 in the denominator, which just opens up a whole lots of different problems and issues with solving. So just right off the bat, we want to make sure that if we get -7, we report no solution. So that's what I see when I look at this denominator. Now, what are we going to do? Let's multiply both sides by x plus 7 to clear the fraction. So to clear the fraction, it looks like this. Some other students might find it easier to take this -5 and put it over 1 and then cross multiply. In either case, you get this right here after cross multiplying. And then we can distribute and add 35 to both sides and divide by -5. And that's what we get as our answer. So does this equal -7? Nope, so it's a valid solution. All right, so that's when there's just 2 terms on either side. If we have 3 terms, then, well, I guess the first thing to do would be to get back down to 2 terms. You can add 2 to both sides of this equation. And then combining the fractions, you get a proportion. 12 over 5 is equal to 6 over x. Cross multiply, and you get 12x equals 30. And then x is equal to eventually 5/2. So that's one technique you can use if you're able to get back down to a fraction equals a fraction. Notice it would require that this term and this term be like terms, and they are. But there's another way you can do it. Another way that you can think about it is this. What if you just cleared the fraction? I know this might be a little bit harder to think about, but it's actually the way to solve more complicated equations, so I want to introduce it here. What is the least common denominator of all these fractions? Well, there's a 5 and there's an x, so the least common multiple between 5 and x is 5x. So what you can do is you can multiply both sides of the equation by 5x. That will ensure that we clear the fraction. And once you clear the fraction, these things get a lot easier. It's the fraction that makes it hard. So what do we get when we multiply both sides of the equation by 5x, the least common denominator? Over here, the 5's cancel out, and we just have 2x. Here, let's distribute. 5x times 6 over x is going to be 5 times 6 is 30, and x cancel, so it's just 30 here. And then distribute 5x minus 2 to get minus 10x. Okay, so then we got this equation right here, and then when you add 10x to both sides, notice you get here 12x equals 30, and it's the same. It still yields the same answer. Note, I wanted to make sure, maybe I should have talked about this at the beginning, but here, looking at the denominator, we have to make sure that we don't ever try and say that x should equal 0. It's just not it's impossibly one of the solutions, because if you try and sub it into the original, you get a 0 in the denominator. All right, let's go over here. Oh, factor everything. That's one of the big thoughts for today. So I see a greatest common factor between 3v and 18. So, maybe even before that, I should note that we really don't want to ever try and say that v is equal to 6. That just can't be one of the solutions. If it is, you get zeros in the denominators and it just doesn't work. Okay, so I'm going to factor this. Oh, and I can factor the numerator also to cancel out the 3's. So once I do that, I can. There it is. Note x cannot equal 6. So once I cancel out the 3's, I'm left with this. I see the same thing on both sides. 2 over v minus 6, 2 over v minus 6. I'm going to subtract from both sides. And I get negative 3 is equal to 0, which is a false statement. So therefore, there is no solution. If I wanted to, at this point, what I could have done is there were 2 routes here. I could have, instead of combining the like terms, there's a something over v minus 6 and a something over v minus 6, so I can subtract both of them from both sides. If I wanted to, I could multiply both sides by the least common multiple, least common denominator. In this case, it was 5x. In this case, it would have been v minus 6, so I could have canceled out the fraction by multiplying both sides by v minus 6. I still would have gotten no solution. So, and I can show you what that looks like later on in class if you like. So before I go, I just want to drop that my favorite Phillies team my favorite MLB team is the Phillies, and it's been that way ever since I was born, thanks to my family living in Philadelphia. So take care, y'all. Have a great day, and I will see you in class.